Hi guys, this is Nishant from IoTGyan again. Today I'll be taking the session on the programming part of the NodeMCU. That is, have you, what is the program that is involved in publishing the data, that is the LDR data to the IBM cloud, as well as subscribing to the commands that are being sent from the NodeRide UI. So let me start the explanation. So here, this is the code. So let's start the explanation. It's like firstly, we have something called as hash include ESP8266 Wi-Fi.h, which means that you are including the Wi-Fi capabilities of ESP8266 under a library, that is ESP8266 Wi-Fi.h. Nextly, as Tapan has explained in the software architecture, that data can be published and subscribed from the cloud. So we make use of pub/sub client library here, which is included in the pub/sub client.h. Nextly, as MQTT is mainly involved in exchange of data in the form of JSON, so we make use of hash include Arduino JSON.h as shown here. It is here. Next, this is the explanation regarding the header files. The next, let's come to the pin that is here, the pin description. That is, as we have three output pins, that is LED1, LED2 and LED3 as shown in the hardware architecture, which are respectively connected to D1, D2, D3 pins. So here I have make use of definitions to define the pin numbers to LED1, LED2 and LED3. Yeah, I'm not using this LED 4 and 5 now, so I'll just put it aside. Next, let's come to constant char star SSID and password. This is my Wi-Fi's name, and that is its ID and its password, right? So this is already defined, so I'm not going to explain it again. Now, this is the most important part. As I've told you in the tutorial, that is exploring the IBM Watson platform, where I told you how you create a device in the IBM cloud, and you'll get the device credentials such as organization ID, device type, device ID, and authentication token. So this is where you'll provide the board with the device credentials. That is, you're telling the IBM cloud that this is the device that you're connecting to the IBM Watson IoT platform through the credentials. That is what this whole definition means. Next, whenever you're connecting to any cloud, you need to specify the server. So the server would by default be organization id dot messaging dot internet of things dot ibmcloud.com. So as we have defined the organization id in the org, so we are using org dot. Next, as a authentication method is by token, so we'll write auth method to be use token auth. Next, we are putting the token here, right? Next, we need to tell the IBM cloud what the client ID is. So the client ID is in this format, which is org device type and device ID. So we write it in a string, that is char. Fine. Next, now as we know that the IBM cloud, whenever you're sending a data from NodeMCU to the IBM cloud, you will make use of a protocol called MQTT. So whenever the word called MQTT comes into your mind, it means that whenever you're sending data from NodeMCU to IBM cloud, it is called publishing. And when you're receiving commands from the IBM cloud to the NodeMCU, it is called subscribing. So MQTT is a protocol which mainly makes use of topics. So here what we have done here is we have shown the NodeMCU the topic to which it needs to publish data, and the topic to which it needs to subscribe. So the publishing topic would be publish topic, and the subscribing topic would be subtopic, and the response generated after it publishes is stored in response topic. If there is any need to manage data, then it makes use of the manage topic. If there is any update in the topic, then it will be stored under the update topic. As we know that device connectivity from a device to the cloud will only be confined to certain interval. So after which it reboots. So that reboot topic is specified here. Nextly, we go to the definition of global declaration of the functions, which is the Wi-Fi connect, that is used for Wi-Fi connectivity, MQTT connect, which is used for igniting the MQTT protocol. This is for INIT managed device. This is used for managing the device. Void published data. This is used for publishing the illumination data. Handle update. This is used for this is invoked whenever a command is sent from the IBM cloud to the node RED. Next we have callback function as usual. Next, we declare the Wi-Fi client as usual, as we do in a conventional Wi-Fi programming. So that is what Wi-Fi client Wi-Fi means. Next, as we make use of the PubSub client library at the beginning, so we are defining the client configurations. That is, we have defined the server at the top. Next we have as it make use of MQTT, so the number would be 1883. And this is the way you just keep your PubSub client ready, so that you can start publishing your data to the IBM cloud by making use of MQTT protocol. Next, here we have a here we have an integer called a publish interval, which means that the public the publishing will not reboot until it's around 30 seconds. The data will be continuously being published to the IBM cloud. Fine. Next we have an int sensor pin, which is A0, because as we know that the LDR is an analog pin, so that is the reason we make use of this A0. Next, this is the sensor value, which is used to store the LDR data. Fine. Till here we have finished the explanation till before void setup. Now let's get on to the setup part. As we know, in conventional Arduino programming, we just use setup for running it once, right? So as data is being published serially, so we make use of serial dot begin, which is used to begin our serial communication. And the preferable baud rate for the node MCU is 115200, that is specified here. Next, we just start printing the data in the next line, so we write serial dot print ln. Next, as discussed in the hardware architecture, we have three output pins, which is D1, D2 and D3. So we have declared D1, D2, D3 as output pins, right? Next, D4 and D5 are not used in our hardware architecture, so there's no need for it. Next, you have Wi-Fi connect, that is for Wi-Fi connectivity, as Wi-Fi should be connected whenever you are as you should have a Wi-Fi access point whenever you are publishing the data to the IBM cloud or subscribing to the commands from the IBM cloud. Next, as the data is being sent through the MQTT protocol, so we call this MQTT connect function. Finally, as we need to manage the data that is being published, so we call the INIT managed device function that we have declared at the top. This is the end of the void setup. Now let's look on to the void loop. Firstly, as the data from the LDR should be stored into some value, so that that can be published into the IBM cloud. So as I told you, int sensor value, that is the sensor value that we have declared at the top. This is where as LDR is an analog sensor, so by making use of analog read, you just store the illumination value that is being sensed by the LDR into the sensor value. That is what this sensor value is equal to analog read of sensor pin means. Now let's get on to the next line, which is this. There's no need for explanation. That is, it will only decide the publish interval. Fine. Next, if client is not connected continuously, that is if it's not in a loop, then you call the MQTT connect as well as INIT managed device functions that you have declared at the top. Because only when the client is connected once, that you can perform the MQTT connect as well as the INIT managed device function. So Next, now comes the place where you define each functions that you call in the setup as well as in the loop. So the first function would be Wi-Fi connect. Under Wi-Fi connect, what you do is you just begin the Wi-Fi through Wi-Fi connection through Wi-Fi dot begin, where you give your SSID and password that you have given at the top. Next, you check whether it is being connected or not. If the status is not connected, then you'll try again. If it is connected, then you'll just print the IP that is assigned by the Wi-Fi router to your NodeMCU. That is what the Wi-Fi connect is all about. To be descriptive, the Wi-Fi connect function in our code is all about connecting the NodeMCU to the Wi-Fi.